Hello and welcome back. In this session, we are going to look at second derivative test for the concavity of functions. Here we have a function y equal to f of x, and let's assume that it is made up of three parts. If I take any 2 points a and b and find the values of the slopes at point A and point B, since it's a straight line, it will have one slope. So the slopes at points A and B will be the same. There will not be any change between the slopes. Now, if I repeat the same process for point C and point D, you can see that the slope at point D is greater than the slope at point C. Now, if we repeat the same process at points E and F, the slope at point F is less than the slope at point E. So the gist of this process is increasing slope refers to concave up function, while decreasing slope refers to concave down function, and no change in slope is a straight line. Here we have a function y equal to f of x, and we're going to find its slope at a particular point. Let's call it f prime at some point x could have some value, and then we're also going to find its slope at a point next to or adjacent to x. Let's call it the value of the slope at x plus h, where h is some positive amount, h is some small amount greater than 0. This expression here gives us the rate of change of slope. We divided the change in slope between 2 points by the distance on the x-axis between those 2 points, and that's the rate of change. And if we calculate this quantity by allowing this h to become very small number, very small positive number, in other words, we find the limiting value. We find the limiting value by letting h become very small, then this will give us the second derivative. And as we discussed earlier, if the slope at point x plus h, where h is a small positive amount, if it is more than the slope at point x, then we have a concave function, and in that case that translates into f double prime x, f double prime of x is greater than 0. However, if the value of the slope at x plus h is less than the slope at point x, then we have f double prime is less than 0, and if they are equal to each other, then we have f double prime of x is equal to 0. The first case corresponds to concave up, the second case corresponds to concave down, and the third case corresponds to no concavity. So a concave up function is basically whose second derivative is positive at every point in an open interval, and if the second derivative is less than 0, then for every point in that interval, then it's a concave down function.